First of all, let's start with the dictionary definition of safety. Simply protection from the risk of harm or injury. We're going to look at that in a couple of different ways, though. We're going to think about machine safety, where we're there really to protect people and for the machine to protect itself from damage. Functional safety is another phrase that we use to describe this space. This really just means that the machine could function incorrectly, and you want to protect the machine and the people from that happening. Kind of as an example of that, when I was working for a machinery manufacturer, we discovered that if someone would accidentally lean up against a couple of the buttons on the control panel, that would create a feedback circuit that would allow the platens of a thermoformer to move in an incorrect fashion and could cause damage. So again, there's safety aspects that we had to look at. We're going to spend most of our time today talking about the manufacturing side of safety, but we're going to briefly allude to it a couple of times where the process industry functional safety fits in. Now, when we're talking about functional safety in the process industry, don't get that confused with intrinsic safety. Intrinsic safety is the phrase we use to describe the fact that devices installed in a process atmosphere that could have a hazardous gas or dust in it, that is a place where a spark could cause an explosion, has to have the energy limited so that that spark is not created. So that's intrinsic safety, and that's not what we're talking about today. Here we're talking about functional safety and machine safety. Differences between process and manufacturing side, one of those differences is the reaction time that's needed. A little bit slower on the process side. The results can be more severe, perhaps, but the reaction time typically is a little slower. Reaction time on the production side, 5 to 150 milliseconds would be fairly typical. When we talk about discrete manufacturing, we also kind of lump in machine or motion control into that category as well. We'll talk a little bit about how ProfiSafe kind of transcends the process, the discrete and the motion side. On the motion side, there are two. We're going to look at this from the process side, then the discrete side. On the process side, the standard is IEC 61511, which has been adopted by ISA 84, and it states that each individual field device shall have its own dedicated wiring to the system input-output. And if we just stop there, this would kind of be the old way, where you have to hardwire everything. But there's an exception now for the case where you have a digital bus communications, but it also has to meet an overall safety performance that basically gives you that same level of protection that you had with dedicated wiring. And there are authorities that test and specify what those requirements are. In the case of the discrete manufacturing side, many of you are probably familiar with NFPA 70, which is the National Electrical Code. NFPA 79 is basically the electrical code for machinery. Up until the 2002 edition of the NFPA 79, you were actually forbidden from doing safety over the bus, and you were forbidden from doing safety logic in a logic controller. Unfortunately, this put us behind Europe and Asia when it came to their safety standards. So that was recognized beginning in 2002 when we started to allow in the U.S., and Canada followed shortly thereafter, to permit us to use safety over the bus and safety logic in a logic controller. Some caveats obviously applied to that. One is that if there is any single failure, these three things have to happen. You have to shut down the machine, obviously, into a safe state. The machine can't get started again until the failure has been corrected. And you have to prevent unintended startup of equipment after the correction of the failure. This is why you always find a reset button in association with your emergency stop button. You have to provide protection using using a PLC and a bus to the same level that you would have if you had done this with hardwiring. And furthermore, you have to do with this, you have to be designed in conformance with an approved standard. Again, there are a couple of standards agencies that we look to that. One of them is TÜV Rheinland North America. Let's look at some of these steps that must be taken as we think about safety. And now some of these steps are steps we need to take, regardless of whether we're using safety over a bus or even hardwired relays. There may be other ways to mitigate some of these risks. But kind of the three major steps are: number one, assess the risk, figure out what the possible hazards are going to be and the consequences of those. Then plan how you're going to mitigate those risks, how you're going to minimize them to the extent that you can. And then finally, you're going to implement that mitigation with whatever plan you've come up with. So plan your mitigation and then go ahead and implement it. Safety always begins with risk assessment. And again, this is true whether we're using a bus or not. So this is perhaps a little bit out of the scope of talking about ProfiSafe, but we wanted to put for you today ProfiSafe in the context of where it fits, kind of between the risk assessment phase, which I'll give you some resources on getting more information on, and also on the hardware side of how the safety is handled there. So in the risk assessment step, what you do is you look at how severe an injury can result as a result of this hazard. You look at how often someone must spend in the area where that hazard is present. And then finally you look at the possibility of eliminating the hazard. What can you really do to eliminate it? Is it something that's going to be easy to do, or is it going to be something that's nearly impossible? There are some tools available to help you through this process and determine what safety integrity level or SIL level that you need. And we're not going to go into this in a lot of detail. I just want you to know that those tools are available. And for more resources on that, when you go to safetybase.com and search on risk assessment, you'll see some webinars and some papers and other information that will help you through the risk assessment process. You will be able to download this PowerPoint presentation as a PDF with these links live. So clicking upon these things that look like hyperlinks in the presentation will take you to the source that it is identifying. Okay, so we've figured out what the risks are. What are we going to do to mitigate those risks? Might be as simple as a sign. You may use physical guarding, something like guarding the timing belt that runs between a motor and a transmission. Might be virtual guarding, where you use something like a light curtain, such that if the beams are interrupted, then you can take the appropriate safety action. And finally, you can do something with electrical circuitry. And of course, when we start to talk about this, now we're talking about ProfiSafe and how we can accomplish safety over the bus using ProfiSafe. Safety over the bus really takes over the correct transmission of messages. So you might kind of simplistically say, now instead of having to do a bunch of wiring and hardwiring this, we've got a single cable that's going to transmit these messages. So really, to oversimplify a bit, ProfiSafe replaces the wires. That's really what it does. And also by using the bus now, we've also made it easy for a logic controller to replace hardwired physical relays. Okay, let's look at the technology just a little bit here. With ProfiSafe, we have this concept of the black channel, and that's what we're representing here. Now, when I think of the black channel, I'm reminded of a black box. Back when I was doing systems integration, there would be times when I needed to convert one kind of signal to another. So how would I do that? Well, I would get a black box, and it would have a Type J thermocouple input on one side, 0 to 10 volt DC signal on the other side, and I didn't really care what happened inside the black box. That was, just a black box. Black channel is kind of similar in that we don't have to care what happens within the black channel, but it is a channel. So what we're doing with the black channel is we are ensuring that whatever message comes in to the black channel is going to be delivered at the controller. Nice thing about the black channel, and this is a concept that we pioneered actually as the PI organization starting over 10 years ago now. This really allows us to not care about the cables, you know, the ASICs, the application-specific integrated circuits that may be in the devices. We don't care about linking devices or connectors or Ethernet switches. All of those are transparent because the black channel basically protects that signal all the way through that. The beauty of this is you don't need safety-rated cable, you don't need safety-rated connectors. The black channel takes care of all that. Well, how does that, what does that really look like? Well, down here in a typical Profibus or Profinet telegram, we can see that there's a part of that telegram that is the data. Now, some of that data is the standard data from standard I/O, and some of it is the fail-safe data, the ProfiSafe data. The ProfiSafe data has some additional treatment that it is given in order to make sure that it is safe. So, what are those? You recall I mentioned that there are organizations that have to approve your ability to be safe. And so these are some of the failure types that they have come up with to say these are the things that can go wrong. If you're going to have a safety over the bus and a safety in a controller, you're going to have to account for these. So how do we account for these? These are the remedies that we've discovered in ProfiSafe to make the safety work. So consecutive numbers, timeout with receipt, assigning a code name to both the sender and the receiver of the data, and doing a CRC check are those 4 ways. So let's just look at a couple of these to get an example of why this is needed and how it works. Let's take repetition. In Profibus, for example, if the cable or the bus is not properly terminated, you could get a reflection. So you could perhaps get something that looks like the same message twice. To prevent that from being a problem, we use a consecutive numbering scheme where each message is going to be numbered so that we know that if we get 2, that's a safety violation and we need to be able to account for that. Similarly, data corruption, you know, that CRC check is going to let us know that the data is corrupt. Masquerade, for example, if a standard message gets corrupted in such a way to look like a fail-safe message, we've got these 3 remedies that will help us prevent that from happening. If any of these things do turn up to be problems and the problem has occurred, we have to be monitoring for that and executing the move to a safe state in a single fail-safe unit. Okay, let's talk now about the kind of the benefits of ProfiSafe. We talked about kind of the technology and how it works behind. So let's look at the benefits both from a business standpoint and from the technical standpoint. Now, as an engineer, I tended to think of the technical benefits first until I read a white paper from ARC. And this is available on our website at us.profibus.com under the white papers section. And this is actually a link to it in the presentation. One of the key summary statements from this white paper is that safety has evolved from being a cost burden to a strategy for improving productivity and reducing downtime. And here we have a list of kind of some of the things that have helped that to be the case. Minimizing the amount of hardware that's required. We're going to refer to later a case study that will show you how much that hardware requirement can be reduced. You can reduce downtime, and of course having more uptime is one of the main benefits of using something like ProfiSafe. You pick up the benefits that are associated with a field bus, for example, the ease of finding out where a problem is. You can also minimize maintenance because basically ProfiSafe is continually monitoring to make sure that the things that it's connected to are in a are actionable, so they will work, eliminating perhaps the need to manually go around and look at or exercise switches and that type of thing. And again, ProfiSafe is an international standard, so you know, no matter where in the world your equipment might wind up, you're going to be able to use the same equipment built to the same standard. On the technical side, ProfiSafe can be used on both Profibus and Profinet. ProfiSafe is what we call an application profile. Sits on top of the communication profiles of Profibus and Profinet. Remember when I talked about the black channel not caring about cable and connectors and so on that it went over, it also doesn't care whether it's going over wires or over a wireless connection. And again, it works across process, discrete, and motion control functions. Again, one of the benefits of a field bus is minimized cabling cost and the associated reduction in installation labor, commissioning time, and so on. The ability to have safety and standard data on the same wire is a plus, although of course we know people who strive to keep them separate. Really no reason to not put them on the same wire. Put safety and standard modules in the same PLC or in the same I/O rack, and you can do safety programming with the same tools that you're already familiar with for the standard programming. You find it's easier to troubleshoot because of the tools that are available to you as a field bus, and also because of the ability to put information into an HMI. For example, back in the old days when I was a systems integrator, this was before 2002, and the NFPA 79 allowed safety over a bus. If we had an installation where there were a lot of guards with just a latch on them that could be easily opened, we had to have a limit switch on each one of those to tell us that it opened. And if those are just wired in series, it's going to be tough to figure out which one jiggled loose at a particular time. With something like ProfiSafe, it's going to be very easy to find out which switch caused you the problem. A couple other technical benefits here. Because you can now kind of segregate your safety scenarios, it may be possible to shut down just part of a machine or part of a line instead of the whole thing if you're going to contain the safe state to just that. One of the new things that's available now is ProfiSafe and ProfiDrive together. This basically means that prior to the availability of this standard, the only thing you could do with a drive to take it to a safe state was to remove the power. And if it needed to stop right away, then maybe you needed to add an air brake or something like that. Well, it may be that removing the power is not the safest thing that you can do. Perhaps the safest thing is to move to a particular position or to maintain a certain tension. Let's say you're making razor blades, so you have a long string of very sharp steel going through the machine. It may be more important to maintain a certain tension on that steel so that it doesn't kind of flop all over the plant. There are other intelligent safety devices now as well. Take something like the laser scanner that we're showing down here. It's pretty easy just to have a single place where you can say if the operator or someone steps into this area, then I'm going to shut the machine down. With the kinds of machines that we have now, for example, the laser scanners, we can actually add whoops, one slide too far, sorry about that. We can actually add an area to indicate that there may be a warning issued at this point instead of just shutting the machine down.